So we have these final two sections of Module 6. So we're getting more into solving quadratics. So in the last section, we were solving a problem that had a square root in it. Now we're doing the opposite and solving a problem that has a square in it. Okay, so again, we want to remember that the opposite of squaring something is taking the square root. So for problems that have something squared in it, you will isolate whatever is squared first. Then you'll take the square root of both sides. The really important thing here is that when you take the square root, you're going to do plus or minus. So these are all going to have two solutions. Okay, so I would write that down here, two solutions. Okay, so if I take the square root of both sides of this, I'm going to go square root of 2x plus 3 squared equals square root of 49. And I'm doing plus or minus. Now on this side, it doesn't really matter because it's just going to cancel out this squared. But on this side, this will matter because then that gives you two solutions. That gives you a positive 7 and a negative 7. Okay, so if you need to simplify the radical, go ahead and do that. This one you do not. So this comes down like this. 2x plus 3 equals plus or minus 7. Okay, then you're going to split this into two equations. So the first equation would be 2x plus 3 equals positive 7. And then the second equation would be 2x plus 3 equals negative 7. And then we're going to solve. Because it is plus or minus, you will get two solutions. So our first solution will subtract a 3. We're going to get 2x equals 7 minus 3. That'll give us 4. Then we'll divide both sides by 2, and we'll get x equals 2. Okay, but if I take a test and I leave it just like that, I'm only going to get half credit. Okay, so I also have to go over here, subtract a 3. I get negative 7 minus 3 will give me a negative 10. 3's will cancel over here, bring down 2x. Then I will divide both sides by 2, and I'll get x equals negative 5. So there I have my two solutions, 2 and negative 5, and I would just separate those solutions with a comma. And we can also check that in the original problem. Okay, let's see. So I can see it. 2x plus 3 squared equals 49. Okay. So let's try that with the 2. So 2, let's see, 2 times 2 plus 3, and then we square that. That's 49. Yes, that is. And then 2 times negative 5 squared plus 3. Oh, I squared. Why did I square that? Never mind. 2 times negative 5 plus 3, and then square. I squared the negative 5. Negative 7, and then I square that. 49. All right, so let's look at example 2. This looks very similar to the last one. What is different? It has a negative 49. Good. Can I solve it? No, we can still have two solutions. I can still solve this. Do you guys remember what we learned about what happens when I have a negative underneath the radical? We use the I. Very good. So we're just going to use the I in this case. So here we're going to do plus or minus the square root on both sides. This will give us, these will cancel. So 2x plus 3 will come out. And then that'll be plus or minus 7i. Now, when I split this into two equations, I go 2x plus 3 equals positive 7i. And then 2x plus 3 equals negative 7i. So here's what will end up happening here. I subtract a 3 from both sides. I cannot do 3 from 7i because they're not like terms. Remember, we treat that I like we treat a variable. So I write it next to it. So I'm going to go like this. 2x equals, and put the 3 first because you want the I to be last. So negative 3 plus 7i, and then divide everything by 2. Okay, so it would look like that. Or if you split that, you're going to go x equals negative 3 over 2 plus 7 over 2, and then stick that I in the middle like that. So you might see it like that on multiple choice. And then we're going to do the same thing with the negative 7i. So I subtract a 3 from both sides. You get 2x equals negative 3 minus 7i. And then again, divide by 2. Okay, that cancels over here. And again, if you split that, you have comma for your second answer, negative 3 over 2, minus 7 over 2i. So these are almost identical. They're just conjugates of each other because we had the I. We couldn't actually combine the terms. So let's look at a couple of examples. So even though this does not have a parentheses in it, it still has a squared term that I can solve. Okay, I can go here and I could actually solve this by factoring, but we're going to solve just by solving. So we can add a 35 to both sides, and that'll give us 5x squared equals 35. Then we'll divide by 5. So we're still isolating the square term. We're basically just solving for x, except now when we get to the answer, now we take the square root. So we just have one more step here. So I would take plus or minus the square root of 7, and that'll give us x. So x will equal positive square root of 7, negative square root of 7. All right, example 4. Okay, we're going to isolate the square term first. So we would take this 45, subtract from both sides. These are going to cancel. I'm going to get x plus 6 squared equals 90 minus 45. That would be 45. Now our square term's isolated, so we'll do plus or minus the square root on both sides. Okay, this is freed from that squared, from the parentheses, so you have x plus 6. Now this one, a little different. I can't take the square root of 45. Okay, well I can, but it's not a perfect square. So I can bring that down, but I want to simplify it. So remember how to simplify radicals. Let's see what we have here. What's a perfect square that goes into 45? Think about our factors. 9. Yeah, 9 times 5. 45. Square root of 9 is 3. So this is going to be plus or minus 3 root 5. And then here what I can do, let me just write this with a little more room, because when it's like that with the radical where it's still going to stay in the radical. Where's my pen? There it is. So plus or minus 3 root 5. I just need to bring the 6 over. So I'm just going to slip it right there in front. And I can leave the answer like that. -6 plus or minus 3 root 5. If you are forced to separate them, you can just -6 plus 3 root 5, -6 minus 3 root 5. Okay, so try that with these two problems here, and then we'll go over them. Okay, so for number 1, we have to isolate the squared term first. So I'm going to start with adding 16 to both sides. 84 plus 16 is going to give me 100. So I'm going to have 5 times x plus 3 squared equals 100. Now, a lot of you went either straight into square root or you tried to distribute this 5. You cannot take the square root until this is isolated. This is not isolated because of the 5 in front of it. You also cannot distribute this because order of operations means I would have to do the exponent first. If I did this exponent and multiplied this out and then distributed the 5, that would be doing way too much work and it would make my problem 10 times harder. Okay, so we don't want to do that. We're undoing all of this, so we're working backwards. So we want to get rid of this 5 times by dividing, because when I do that, those just go away. I'm undoing this so that I can isolate the x plus 3 squared. 100 divided by 5 is going to give me 20. Now I can do the plus or minus square root. Okay, that will give me x plus 3 equals plus or minus the square root of 20, which I can simplify. What will that simplify to? 4 and 5. And the square root of 4 is going to be 2. So that's going to be plus or minus 2 root 5. Then I can move the 3 over, slip it right in front of there. So you get x equals -3 plus or minus 2 root 5. Okay, let's look at number 2. So to isolate this, I'm going to want to subtract the 18, which will give me x plus 4 squared equals -18. Okay, then I'm going to do plus or minus the square root on both sides. Cancels out over here. Now, this 18 is negative. What do I do with that negative? Yeah, make it positive. Put the I right there in front of it. Okay, it's kind of hard to see. Hold on. Okay, so I have the I right there in front of it. Now, 18 can be broken down to what times what here? 9 times 2. Square root of 9 is 3. So this will give us a plus or minus I3, so 3I root 2. Okay, the I came from the negative. Pull that down. The 3 from the square root of 9. The 2 stays in the radical. Now I bring down this part, x plus 4. And then, move this over here. I'm going to take the 4, subtract it, put that right in front here. So this is going to be x equals -4 plus or minus 3I root 2. Anybody have any questions on either of those two problems? All right.